Hey, hi and welcome back. So in previous video, we were left with the reset pin. So we will complete the connection of reset pin first in this video and later we will complete the rest of the connections. Okay. So now let's start with this video. So where is reset pin? This is basically reset pin and it's connected here. Along with that, the connection is coming. Alright, so the connection is not coming here. Alright, so we have to connect this point and this point is actually connected to this point. Okay. So I will just maximize this one. Now here what we will do, straight away from here, we will actually go to the bottom layer. So let's go to the top layer and later we can actually, okay. Now here if you see, I'm actually trying to go through this path, but the eagle is actually restricting me because this path is actually a clearance path. There will be, minimum distance from the track towards the edge of PCB. Generally, that distance is going to be 3 or 4 millimeter. Yeah, but not 3 or 4 millimeter. Yeah, 3 or 4 millimeter. So we try to keep the track away from the edge of the PCB because while during the manufacturing of the PCB, your track may, it may get cut. Okay, if it is too close to the edge of PCB. That's the reason we actually keep little bit spacing between the track and the edge of the PCB. And that's the reason this Eagle software is not allowing me to, lay the track from here. So what I will do now, I will go to the top layer and from top layer, I will lay the track. Okay. So for that, I will have to do little changes. So let's not bring this track from here. Let's bring this track like this. Okay. And later we will connect it here. So you will get that in a moment. So let me rip up this reset track and let's reroute this track. So I will go to the bottom layer first. Okay. I will go to the bottom layer and later I will do the connection like this. Or what I can do, I will just rip up this and I will go this way. Okay. So I will go like this. So I will rip up this track now. So I will go like this. Okay. So I will go to the bottom layer, top layer here. So for that, first of all, let me go to the top layer and okay, I can't go to the top layer here because this particular SCK track will actually come in between. So I will just first of all, let me rip up this track, reset track. It's of no use to us. And later, I will just bring this track here and later, okay, what I will do, I will lay the track like this. You can actually do a bit. Okay, so from here, there is a problem. I can't go like this. So there are a lot of problems here. And alright, so I will move this track like this. Alright, and I will just move this track here. I will make the space. So we have to make the space. And I will go to the top layer here. I will place the wire. Alright, so first of all, let me move this track because there is not much clearance here. So I will go to the bottom layer here. Sorry, top layer. I will place this wire here. And then ultimately we are connecting this reset connection. Now you will see that there is a lot of complexity here. So first of all, let's make space for all the connections. So I will place this wire here. And here we have to make sure again it's not connecting or it's not shorting this ground. Now let me move this TX pin and I will move this wire like this. I will just move this motor 2 in pin like this. I will move all these tracks now, not pin, tracks. And I will make the appropriate space for all the tracks. Okay, fine. Now we are left with, let me change the background color to black. Okay, I think I did it for schematic. Okay, so we are left with this 5-volt connection. Then, okay, so let me go to the schematic editor. And let's check these connections. So most of the connections are actually ground connections now. We are almost done with all the connections. We are actually left with this particular connection. So let's connect this connection. So for that, again, I will change the user interface color to white. And let's do this connection first. So first of all, I will rip up this connection, and later I'm just going to lay the track through this gap, and later we can directly connect here. We don't have to go to the bottom layer. All right. So here again, I will have to make some space for this particular track. So let's move this debug track, debug TX line like this. I will move this via like this. All right. And we can go like this. All right. And then I will move this reset track like this. So this is actually the fair connection. Alright, so there is enough space between debug TX and debug RX, and also these pins MISO, MOSI, SCK, these are actually the programming pins. So we have to make sure there is enough enough space between these pins also. So if you want, you can actually move these motor enable pins, but there should be enough space between this MISO, MOSI, because when we will program the controller, the signal which will be traveling from these pins MISO, MOSI, SCK, they will be of 2 MHz, okay, 2 or 4 MHz. So you have to keep enough spacing, and accordingly you have to route. Okay, so let me check everything is fine here. Now again, let me go to the background of black color. Now let's connect this connection, which is 5V connection. So I will just click on show. So 5V connection, we have to power this part. So again, I will go to the white. Okay, and let's do the connection here. So again, this particular IC is actually not going to drain much current. It's going to be less than 100 milliampere, right? So we can go for a track width of 100 mil. So I'm just going to select the grid as grid unit as mil, and then I will do the connection here like this. I will go to the bottom layer, and later again I will go to the top layer, and this like this I will do the connection. You can also increase the width of this particular track. And one more thing I want to tell you here is the width of this particular wire that we are using. The width of this wire is actually just a second, let me change the unit to millimeter. Okay, and let me go to the properties, and you can see the drill wire, this particular internal diameter, or if you see the drill diameter is actually 0.35 millimeter. So this wire is actually capable of passing 1 amperes of current. Okay, again there is a calculator for the wire, and in the wires calculator you can check how much current this particular wire can pass. So it can pass a current maximum up to 1 amperes. So we don't have to care much about at this moment while doing the wire connection. But when you are passing very high current, even more than 1 or 2 ampere, then you will have to increase the size of wire, which you can edit from here. But at this moment, this diameter is actually more than enough for us, and we are done with the connection of this IC. All right, now again let me go to let me check which connections are left. So again here we have to connect this plus 5V connection, and this connection will come from this pin. All right, so first of all, let's connect all these pins together, and for that I will again change the user interface color to white. So let's quickly do the connections now, and this is basically the preset, and from here I will go towards this pull-up resistor. This is actually the pull-up resistor, right? So this is pull up register. Then from this register, the connection is going towards this switch. So you can do this connection or you can connect it in a better way. I'm going to provide you, the proper layout which you can use when you will create the layout as a reference. And after that, this connection I will do directly like this. And now we are just left with this, so I can connect this directly here. Okay, so it's a track width of 10 mil. It's fine. Now most of the connections that we are left with are basically the ground connection. So let me go to the user interface and let me change the color to black. And let me click on show. And you can see all these connections are just the ground connection. I'm just checking whether if there is any connection other than the ground connection. So we are just left with all the ground connection now, and we are not left with any signal connection. Okay, so with this we have completed the connections of all the signals on our hardware. So you have to always remember two things. You have to remember the track width, what track width should be used, for a particular connection, and the track width will be decided by the current which is going to flow through that particular track. Then the second thing is the distance between the tracks. Okay, so you have to check whether the signal, what kind of signal it is. Either it is just on-off signal, or it is a high frequency signal. Not high frequency, but the signal which is going to pass through that particular pin, whether it's a switching signal or not. Okay, and what's basically the frequency of that signal. And considering that, you have to provide enough isolation between, like we did in case of RxTX. In the same way, we did it in case of MOSI, MISO, SCK, okay, these tracks. So you need to place these tracks at a, appropriate distance. Okay, the purpose here is we don't want the track which is around that particular track to influence, the signal, or we don't want any kind of coupling between those two signals. Okay, that's the reason we are actually we are providing enough separation between the tracks. Alright, so we are done with all the connections, and now we are just left with the ground connections. Okay, so in next video, we will connect all the ground connections on our hardware, and also I will show you how to connect those ground connections using the polygon. Okay, so I will see you in the next video now.